Imagine a universe where no possibility is ever left behind. In the many worlds interpretation of quantum mechanics, every single potential outcome of a quantum event actually happens in its own separate branch of reality. Nothing ever fails to happen. This creates a severe logical headache. If every outcome is guaranteed to exist, what does it mean to say one event is more probable than another? Asking for the probability of a coin landing on heads when both heads and tails are guaranteed to occur is like asking for the probability that Tuesday exists. Even if we could define probability here, we run into a mathematical wall. If all these branching realities are equally real, basic logic suggests we should just count them. If a measurement splits the universe into two branches, each should get a 50% chance. This chart compares that naive branch counting on the left with actual laboratory data on the right. In the real world, quantum outcomes follow the Born rule. The Born rule is a mathematical formula that assigns probabilities based on the squared amplitude of a quantum wave. Naive branch counting almost never matches these physical observations. Because the theory is at odds with empirical reality, it is forced to manufacture a rationale for probability to survive. It must find a way to make some branches fatter or more significant than others, even though they are all equally real. To fix this, theorists have proposed a few clever patches. The most prominent is the decision theoretic strategy. The idea is that a rational person living in a branching universe must place bets on future outcomes as if standard probabilities exist. The problem is that the rules of rationality used to build this argument rely on distinct, well-defined branches. In reality, quantum branching is a messy, emergent process. These rules are philosophical fictions stretched over a physical structure that isn't robust enough to support them. And there is a much deeper gap. Telling an observer how they should rationally wager on a future measurement does nothing to explain the actual sequence of zeros and ones recorded by machines in a physics lab. This approach answers the wrong question. It dictates how a human agent should act regarding the future. It doesn't describe the physical mechanisms of how the universe distributes those outcomes across reality. Substituting a psychological expectation for a hard physical law leaves the underlying issue untouched. The mathematical crisis of how to get the right numbers out of the theory remains unresolved. A second proposed patch relies on self-locating uncertainty. The argument suggests that immediately after a measurement, there is a brief window where an observer genuinely does not know which branch they have ended up on, and this ignorance creates probability. But this uncertainty breaks down upon closer inspection. The simul observer who existed before the measurement is not identical to just one of the future versions. Because the observer splits into multiple people, there is no single true path they're ignorant of. A third strategy attempts to derive probability from the environmental symmetries of entangled quantum states. It looks at how systems interact with their surroundings and tries to extract the math of probability from those physical symmetries. Yet this argument assumes from the very beginning that probabilities are intrinsically tied to quantum states. It shows what form probabilities must take if they exist, rather than proving they can meaningfully exist in a universe where everything happens. This diagram illustrates the structural failure that undermines all of these strategies. They all rely on a vicious logical circle. To get probability, you first need well-defined branches. To get branches, you need decoherence, the process that separates quantum states. And to define decoherence, you have to use the math of the Born rule. The final step of the loop connects back to the start. The foundational physics require the very rule they claim to be proving. You cannot derive the Born rule if you are secretly using it to define the structure of your universe in the first place. Because all three of these major theoretical patches are built upon this inescapable circular logic, the entire machine falls apart. The framework is defective. After 7 decades of effort, the probability problem remains unresolved. Despite the complexity of these proposed solutions, none have managed to bridge the gap between a branching universe and the statistics we see in our experiments. Defenders often argue that many worlds is simpler because it removes the concept of quantum collapse, but trading one clean mathematical postulate for an infinite matrix of unanswerable paradoxes is not theoretical parsimony. Occam's razor has strict limits. Relying on elaborate, circular machinery just to explain why we see standard probabilities in a laboratory violates those boundaries. The persistent failure to derive probability from a branching universe suggests that probability isn't a psychological illusion, it's a sign of real indeterminacy. It points toward a universe that actually collapses into a single, definite state. This state of real indeterminacy is the necessary ground for conscious agency. For consciousness to bias a quantum outcome, there must be a single path to influence, not a deterministic tree where every possibility is already guaranteed. Many worlds denies this possibility by making every outcome inevitable. Rather than an illusion generated through mathematical trickery, the Born rule must be accepted as a fundamental law of nature. It is an honest statement of how the universe actually works. Empirical reality demands genuine uncertainty. To match the universe we actually observe, we are forced to reach a complete abandonment of the many worlds illusion and accept that some possibilities truly do not happen.